Welcome to Chapter 3, Section 2, Comparing and Ordering Decimals. Now, an inequality is a mathematical sentence indicating that two qualities are not equivalent. Or you could also just say are not equal. You're going to want to make sure you put in here that that is considered a less than. And I mean, if you look at it, it actually looks like an L. It looks like an L shape. A lot of people draw little alligator teeth because the alligator eats the bigger number. You know, if you had to choose between a big steak and a little steak, you'd probably go for the big one. So that means that when you're looking at a less than, you would say 2 less than 3. 2 is less than 3. All right, you also have a greater than, like this. So I think these are the only two choices we're going to be working with today. So a greater than and a less than. The less than looks like an L. The less part is first. The less part is first. Here, the greater part is first. So taking a look at this, the table below lists the final winning percents for several American League baseball teams in a recent year. Use greater than or less than to compare New York's percent with Cleveland's percent. So we're looking at, so you first have to know what we're looking at. We are looking at New York and Cleveland. So this percentage compared to this percentage. All right, so you have to determine which one is, if it's one is less than or greater than the other. So let's go ahead and use a place value. Now, using a place value, what that means is you line it up at the decimal, and we're going to compare the numbers based on their place value. So you're going to start from left to right, and you're going to compare the numbers. So, and when you finally get to one that's bigger or smaller than the other, then you change it, or that's when you can stop. So 5, they are the same number. So currently, these two numbers are the same. When we get to 9 and 6, which number is bigger? I hope you're all saying that the 9 is bigger. If this number, if the 9 is bigger, then it means this whole thing, this whole decimal is bigger. So there are two ways you could write this. You could say 0.594, that's New York. And since it's bigger, you say greater than 0.562, which is Cleveland. So 0.594 is greater than 0.562. You could reverse this and put Cleveland first. But if you reverse the numbers, you also have to reverse the inequality. So instead of greater than, you're going to have a less than. So Cleveland's percentage is less than New York's. New York's is greater than Cleveland's, using place values. Using a number line. Well, we just got done talking about Chapter 2 with number lines. Here's 0, negative 0.1, negative 0.2, negative 0.5. Over on this side, let's put 0.1, 0.2, 0.3, 0.4, 0.5. And we'll go to 0.6. So if we look at this on the table, on a number line, we're looking at 0.594. That's almost 0.6. So this number right here is New York's. Cleveland, 0.562. 0.562 is pretty much right here. So now according to the number line, you would put Cleveland first. And since Cleveland is to the left, that means that is less than New York's. So those are the two ways you could set this up. All right, so in Mr. Smith's math class, 29.65% of the students earned a grade of an A at the end of the semester. In Mrs. Dempsey's class, 29.85 of the students earned a grade at the end of the semester. Use a greater than or a less than to compare this percents in Miss Smith's class. So let's take a look by place value. 29.65 or 29.85. The top one is Smith's class, the bottom one is Dempsey's. So if we look, the 2 and the 2 line up. So far it's the same. 9 and a 9, those are the same. When we get to this right here, the tens place, or tenths place, you see that the 8 is bigger. Since the 8 is bigger, that means the whole bottom number is larger. So you say the whole, since 29.65, sorry, is smaller than or less than 29.85. You could have also said that S is less than D. So that's how you can compare these numbers. All right, another vocabulary word is equivalent decimals. Decimals that name the same number are called equivalent decimals. Decimals that name the same number are called equivalent decimals. That means if you have 0.25, an equivalent decimal would be 0.250. If you had 0.205, an equivalent decimal would be 2050. All right, so ordering decimals. Or we're going to order 25, 25.1. We're going to put them from least to greatest. So when we were doing least to greatest for median, the numbers were probably pretty nice. There were no decimals. Now we're dealing with decimals. So what they did, what we do first is first line up the decimal points. So we lined up all the decimal points, and here's 25, 25.1, and so on. And then we made them put zeros so they would have the final, same final place value. So basically, we want to make sure all of them have 2 decimal points. So now when we compare these, 25.0, 25.1, 24.3, 25.0, when you compare these numbers, 25.0, 25.1, those are smaller. But let's take a look at 25.03 and 25.00. So 25 and 25.03. So 25 is 25.00. You can see that the 2 is the same, the 5 is the same, and the 0 is the same. So now you have to look at the last decimal. And since 25.03 is greater than, the 3 is bigger than the 0, so that means right here should be 25 by itself. And the last one is 25.1. All right, order these up. So let's look at them. Here's 71, 71.04, 70.89, 71.4. All right, so 71, 71, 71, 70. The 7s are all the same, but when we get here, the 0 is our first number. All right, now we compare decimals. Well, the 71 should become 71.00, 71.40, 71, 7, 1, 7711, 0004. Well, the 0004 is, the 4 is definitely bigger. So that means 71.00 is second. Then 71.04. And the last one is 71.40. All right, and I think that's pretty much all you've got to do. So these are your practice problems that we'll do in class, and you should make sure to do the CYUs.